Graphing linear equations in two variables. In this lesson, you will learn how to use a table, equation, and graph given a situation in two variables. What do we already know? Well, we know that we have a coordinate plane with x, our x-axis, and our y-axis, and the point where they intersect right here, that is the point 0, 0, also called the origin. In the first quadrant, we have positive values for x, so x is greater than 0, and we have positive values for y, so y is greater than 0. In quadrant 2, we have negative values for x, so x is less than 0, and positive values for y, so y is greater than 0. In quadrant 3, we have negative values for x, so x is less than 0, and negative values for y, so y is less than 0. And finally, in quadrant 4, we have positive values for x, so x is greater than 0, and negative values for y, so y is less than 0. This is what we call the Cartesian coordinate plane. So whenever we refer to the coordinate plane, we're referring to this x and y axes, and each of the coordinates, which are ordered pairs, the coordinates are x and y, they tell you which quadrant you're in, the location of the point for that coordinate. So let's try a problem. The parking garage at SU charges $1 for the first hour and 50 cents for each half hour after the first hour. For this situation, set up a table, write an equation, and graph it. So here's our table, and here's our grid for when we need to graph. So let's pick up the pen. All right, so to write our table, we're going to say the number of hours, and then we're also going to look at the total cost. Those are the two variables in this problem, the number of hours and the total cost. So if we park for 0 hours, we're not paying anything. And that's almost irrelevant in this problem, but we'll take a look at that in a minute. If we park for 1 hour, we pay $1. If we park for 2 hours, we pay $1.50. If we park for 3 hours, we pay $2. If we park for 4 hours, we pay $2.50. And if we park for 5 hours, we pay $3. And we can continue our table with the same pattern. So now let's take a look at our graph. Let's say, okay, here's the x-axis, here's the y-axis, and let's say that the y is the total cost and the x is the number of hours. All right, so we'll make each line 1 unit. So there's our number of hours, and here is our total cost. All right, so now we can mark the point 0, 0, but we really don't want to. So let's take a look at 1 hour. So if we park for 1 hour, our total cost is $1. If we park for 2 hours, our total cost is $1.50. If we park for 3 hours, our total cost is $2. If we park for 4 hours, our total cost is $2.50. And if we park for 5 hours, our total cost is $3. So when you connect those points, and I know they're not exactly right, but hopefully you get the gist. It's very difficult to draw a straight line on this, so bear with me. But so here's our line, and now we need to come up with an equation. Well, if we could draw a very straight line, we would see that our slope is as we go up 1 unit, 1 whole unit, we're going to the right 2 units. So our slope, which was rise over run, our rise is 1, we go up 1, and let's show that there, pen color, let's go with green. So our rise is 1. That's equals, not less than. This pen, I tell you. All right, and then our run is how far to the right we go, and that was 2 units. So our slope, which was rise over run. So our slope is 1/2. Okay, so y equals 1/2 x. And then we need to see, well, what is our y-intercept? So plus some b. Okay, so let's take one of our points, and we don't want to use this one because that actually would not be part of our straight line. It would cause our line to curve a little. So let's take 1 and 1 because it's easy. So 1 equals 1/2 times 1 plus b. Well, that becomes 1 equals 1/2 plus b. Subtract the 1/2, so negative 1/2 equals b. So the equation of our line is going to be y equals 1/2 x minus 1/2. And you can write that as a decimal if you choose. So it would be y equals 0.5 x minus 0.5. And there we've set up a table, graphed it, and then come up with the equation. You can do those in any order you choose, but you need to set up all 3 so we can make the connections between each of the 3 parts of the problem. All right, so now you're going to try a problem. So now you're going to try this problem on your own. Jeff went on a trip. Before leaving, he filled up his gas tank. He drove 273 miles and stopped to top off his tank by putting 10.5 gallons into the tank. Then he drove 227.5 miles and stopped again and topped off the tank, putting 8.75 gallons into it. Then he drove 286 miles to his destination and put 11 gallons into the tank to fill it. How many miles per gallon does his car get? So for this situation, you're going to set up a table, you're going to write an equation, and you're going to graph it. So you're going to be using all of the information given to you in the problem to set up a table, to graph it, and set up an equation. And then after you've done all of those things, I want to know how many miles per gallon his car gets. So try that on your own, and we'll talk about it in class.